Session 11.1 Linear Correlation. If I do have two variables, the first one, that will be the number of hours of sleeping for students. And the second variable will be the GPA at the college of that students. Now, I want to determine whether a relationship exists between these two variables. So, how could we find it out? Correlation. A correlation exists between two variables when the values of one variable are somehow associated with the values of the other variable. So we do have a different kinds of correlation, and for our course, we only want to learn about the linear correlation. A linear correlation exists between two variables when there is a correlation and the plot points of paired data result in a pattern that can be approximated by a straight line. So scatterplot will be our tool for examining relationship between two numerical variables. So first, we do have the ordered pair x and y. Each ordered pair in the scatterplot that will be represent one sample. And usually, we'll be using the technology or computer software to create the scatterplot. And for our class, we'll be using the TI-84 graphic calculator. Let's look at the scatterplots. First one, you could see when x is increasing, then the y will be tends to decrease. So you could look at the slope here. The slope, that will be the negative slope because it's going down. So we're gonna say this is the negative linear correlation. And we could draw the straight line in here. And all those points is gonna be around this straight line. So we believe there is a linear correlation between these two variables. Second one, when x is increasing, y is also tends to increase. And also, when I draw the straight line in here, the slope will become positive because this is increasing. So, and all those points that will be around this straight line. So we believe there is a linear correlation between these two variables. And we call this as a positive linear correlation. Okay, look at this one. We do have all the data in here, but there's no pattern for the scatterplot. And we can't draw the straight line in here. So we believe there is no correlation between these two variables. Last one, we can't draw the straight lines in this graph in here. So we believe there is no linear correlation. However, you could see some kind of pattern in here. So we believe there is a correlation, but just not the linear one. So for the last picture in here, we only can make the conclusion that there is non-linear correlation. Okay, there is no linear correlation, but they may have some other kinds of correlation. Interpreting correlation using a scatterplot can be subjective. A more precise way to measure the type and strength of a linear correlation between two variables is to calculate correlation coefficient. Okay, correlation coefficient R. The correlation coefficient R measures the strength of the linear correlation between the pair quantitative x and the y values in the sample. Look at the first scatterplot here. I could draw the straight line in here, and then all the points is gonna be on this straight line. So first, the slope is gonna be positive. And then look at the R. R is gonna be equal to 1, and all the points is gonna be on the straight line. So we call this is gonna be perfect positive correlation. Second one, I still can draw the straight line here, but this time, not all the points is gonna be on the straight line. But all the points is really close to around this straight line here. And the direction is gonna be positive. So we're gonna say this is gonna be strong positive correlation. And then the R, that will be equal to 0.81. Okay, 0.81, that is really close to 1 in here. And that's why we call this as a strong positive correlation. Last one, I still can draw the straight line in here, but obviously not all the points is really close to this straight line. And the direction still like increasing. So this is gonna be the positive slope. Look at the R, that is gonna be equal to 0.45. So we're gonna call this is gonna be the weak positive correlation. Okay, the fourth picture. Now you could see the slope is gonna be decreasing. Okay, so that will be the negative slope. And then I can draw the line in here, and then all the points is gonna be on the straight line. So we're gonna call this is gonna be the perfect negative correlation. Okay, so R is gonna be equal to -1. This one, I can draw the straight line here, and then all the points is really close to the straight line. So we're gonna say this is gonna be strong negative correlation. And then you could see the R, the correlation coefficient, is gonna be -0.92. Last one. They don't have any patterns in here, right? So believe there is no linear correlation between these two variables. And then look at the R. R, that will be equal to 0.04. Okay, so that's really close to 0. And because there is no certain pattern for the scatter plot, so we could draw the conclusion saying that there is no correlation. It is important to remember that if R is close to 0, it does not mean that there is no relationship between X and Y. We only can draw the conclusion saying there is no linear relation. Some properties of the R in here. Assume R is the linear correlation coefficient for the correlation between two numerical variables. Then first, the values of R is always in between -1 to 1. Okay, R is gonna be in between -1 to 1 here. If R is positive, then the variables are positively correlated. When R is positive, meaning that the slope is also positive. Okay, so they do have a positive correlation. If R is negative, meaning the slope is going to be negative, and then the variables are negatively correlated. When your R is equal to 0, there is no linear correlation. Okay, right? Okay, more properties of the linear correlation coefficient. The larger the value of R, the stronger the linear correlation will be. And if R equal to 1, then the points lie exactly on the line and the correlation is positive. So when R equal to 1, from the previous slide, we do have the example. All the points is going to be on the straight line. And we call perfect positive linear correlation. But when R is going to be equal to -1, means all the points lying exactly on the line and the correlation is negative. So we're gonna say this is a perfect negative linear correlation. When your R, that is from 0.5 to 1, then we could say this is going to be strong positive linear correlation. Or when your R is going to be from -0.5 to -1, we're going to say this is a strong negative linear correlation. But if your R is in between -0.5 to +0.5, we could say there is a weak linear correlation. But when R equal to 0, that is a non-linear correlation. more properties. R is uniqueness, so that's a no unit for the R. And if all values of either variable are converted to a different scale, the value of R does not change. This is talking about when they have a different unit. For example, when we have the variable of height, first time I measure it with the feet. And then I convert it from the feet to centimeters. They have a different scale, but the value of R does not change. The value of R is not affected by the choice of x and y. Interchange all x and the y values and the value of R will not change. So it doesn't matter which variable you use for the x, which variable you use for the y, you're gonna get the same R. R is very sensitive to outliers, which can dramatically affect the value of R. So every time, if we want to find the correlation coefficient R, we have to look at the scatter plot. Make sure there is no outlier, and then we can calculate the R. But if there is outlier on the scatter plot, usually we're gonna remove the outlier, and then we're gonna calculate the R. R is only useful to measure a linear trend. Always graph your data first before computing R to make sure the association is linear. Again, when we want to calculate the R, we have to look at the scatter plot, and the scatter plot have to show there is a linear correlation, and then we're gonna calculate R. If the scatter plot shows that there is a non-linear correlation, that would be meaningless to calculate the R. Common errors involving correlation. Common error to assume that correlation implies causality. A correlation between two variables does not necessarily imply that one causes the other. For example, there is a correlation between the number of the cigarette smoke and the pulse rate, but it would not conclude that the number of the cigarette smoke caused a person's pulse rate to change. You only can say these two variables are associated with each other, but you cannot draw the conclusion saying that one caused another to happen. Another error involves the property of linearity. If there is no linear correlation, there may be some other correlation that's not linear. Remember at the beginning, remember the last picture here? We could see some kind of the pattern here. It's just not the linear one. So when we draw the conclusion, be careful, you only can say this is non-linear correlation. They do have the correlation between these two variables, but just not the linear one. Okay, look at the requirements. Sample of paired data is a simple random sample of quantitative data. Okay, it has to be simple random sample. Second one, visual examination of the scatter plot must confirm that the points approximate a straight line pattern. So before we finding the R, we have to use the sample data to construct the scatter plot. And then we have to make sure they do have the straight line pattern. Outliers must be removed if they are known to be errors. The effect of any other outliers should be considered by calculating R with and without the outliers included. So the outliers will have the big effect for the R. After we look at the scatter plot, if we believe there is outlier, we have to remove it. This is the formula for you guys finding the linear correlation coefficient R. It looks really complicated. Okay, if you guys want to know how to do that, you could use your calculator to help you out. Input the X variable on the L1 and then input the Y data on the L2. Then you're gonna go to the stat, cal, number 2, two variable statistic. Okay, so you're gonna find it out what is your summation xy, what is the summation x, what is the summation y. plug it into this formula and then calculate the R. But for our course, I don't need you guys using this formula, okay? We'll be strictly using the TI-84 calculator to find the correlation coefficient R. And the instruction is a little bit complicated, okay? Let's try to do the example together. Example 1. The table below shows the height and the weight for 6 women. Compute and interpret the R, the correlation coefficient. So now, let's use the calculator to find the R. Okay, let's do it together. First, click on the stat, number 1 added. And then on L1, we're gonna plug in the variable of height. And then the L2, we're gonna plug in the weight of the woman. Okay? Now, click on the stat. Use the arrow button, go to the test. And let's go up. Okay, go up will be faster. Find the linear regression t-test. Okay, linear regression t-test. Enter. So my x variable will be on L1. Y variable is going to be on L2. Frequency. And then this one, always choose the not equal to. Okay. For the regression equation, we're going to talk about it in the session 11.2. Now, go to calculate. Enter. So, scroll down. You're going to find your R. R will be equal to 0.80x09. Okay, write it down here. And then construct a scatter plot. So there is 2 ways to do it. First, we'll be using the graph paper. Try to input the order pair on this graph paper. But before that, I need you guys label the title, x-axis, and the y-axis. So the title, the weight and height. And then x-axis, that will be represent the height here. Y-axis, that will represent the weight. So now we try to label it. We do have from 61 until 70. And then on the y-axis, that will be from 80 to 180. Okay, first one, 61 and 104. 61 and 104, somewhere like here. 62 and 110. And then 63 to 141. 64 to 125. Okay, keep working on it. Okay, you have all this data. And this is gonna be your scatter plot. Okay, now let's try to use your calculator. You already have this screen, and then we're gonna keep going. After you finding the R, you're gonna go second step plot. We're gonna turn on the first one. And then you're gonna choose the first icon here. This is gonna be your scatter plot. My data is gonna be on L1, so second 1 for L1. Second 2 for L2. And then for the mark, it doesn't matter which one you're gonna choose. Okay, I'm gonna choose this guy. Now, I'm gonna click on the zoom. Choose number 9, zoom step. So you're gonna have this picture. Okay, I'm gonna copy this picture, compare for your result, exactly the same thing. Now we're gonna interpret the correlation coefficient R. So first, think about it. If the R is gonna be positive or negative, increasing, going up, right? So that's a positive. And then think about it, it's going to be strong or weak. So this number 0.881, that is close to the 1. So we believe this is going to be strong, positive linear correlation. Okay, second one. I want you guys try. Use your calculator. Okay, go to the stat, go to number 1 added, and then input your L1 and then L2. Find out what is your R. And then use your calculator or the graph paper, construct the scatter plot. Make sure you label the title, x-axis, and the y-axis. And then at the end, interpret the correlation coefficient R. Okay, right? Check your work. Click on the stat. Go to the test. Go up. Find the linear regression t-test. Enter. So my data is on L1 and L2. This guy always choose the not equal to. Go to calculate. Enter. Okay, so you're gonna find your R that's equal to 0.906. Okay, 0.906. And then construct the scatter plot. Label the title, x-axis, and y-axis. So you should have this. Okay, this is talking about the small company has 5 employees. Following table present the number of the years each has been employed and the hourly wage in the dollars. Okay, so do it one by one. 0.5 is gonna be 9.51. And then 1 will be 8.23. Okay, keep going. You should have this. Okay, use your calculator, double check your work. Click on second, y equal to, enter. And then we're gonna choose the first icon. Okay, right? Click on the zoom, number 9, zoom step. So you will have this picture. And then interpret the R. So R close to 1, and this is gonna be positive, strong linear correlation between the number of the years has been employed and the hourly wage. Okay, right? For these sessions, we learn about the linear correlation. And we know how to find out the R, how to interpret the R, and then how to use your calculator to construct the scatter plot and finding the R. That's it.